Picture this: a single aircraft soaring at cruising altitude, simultaneously refueling multiple fighter jets in midair, extending their range far beyond what was previously possible. Now imagine the same aircraft transforming into a strategic transport, carrying troops, armored vehicles, or vital humanitarian supplies across continents, all while maintaining full operational efficiency. This is not science fiction. This is the Airbus A330 multi-role tanker transport, or MRTT, a flying embodiment of versatility, engineering precision, and strategic capability. The story of the A330 MRTT begins with a fundamental problem in modern air warfare: the range limitation of combat aircraft. Fighter jets, bombers, and reconnaissance platforms are powerful, fast, and precise, but their operational endurance is dictated by fuel capacity. Without refueling, their range is constrained, their loiter time over target is limited, and their ability to respond globally is reduced. Traditional ground refueling can never match the flexibility or speed required by contemporary operations. This strategic limitation prompted the development of an aircraft capable of airborne refueling while also serving as a strategic transport. The A330 MRTT emerged as the answer, a platform engineered to combine the performance of a commercial airliner with the specialized systems required for modern military missions. Its dual nature, tanker and transport, requires engineering decisions that balance fuel capacity, structural integrity, aerodynamic efficiency, and system reliability. At first glance, the MRTT resembles the Airbus A330 commercial airliner, but every design choice is dictated by dual operational requirements. The aircraft must sustain long-range flights with heavy fuel loads, maintain stability during mid-air refueling operations, and simultaneously provide the cargo space and structural strength needed for transport missions. The high aspect ratio wings, swept at 30 degrees, optimize lift-to-drag ratio for long-duration flights. These wings, reinforced with additional structural spars, handle the stress of carrying both fuel and internal tanks and cargo in the rear fuselage. The fuselage itself is modified from the commercial A330 platform, with reinforced floors, tie-down points, and modular systems to accommodate pallets, vehicles, and specialized mission equipment. Landing gear is strengthened for heavier takeoff weights, often exceeding 230 tons in fully loaded operations. The aircraft can operate from major air bases worldwide, delivering both fuel and cargo without requiring special runways or infrastructure upgrades. The heart of the MRTT's mission is its refueling capability. The aircraft uses two primary systems, the flying boom and hose-and-drogue. Each system caters to different aircraft types. The boom system provides high-speed fuel transfer, ideal for large aircraft such as bombers or transport planes, while the hose-and-drogue system supports fighters, helicopters, and allied aircraft using compatible refueling probes. Engineering these systems into a commercial airframe requires careful attention to structural loads, aerodynamic interference, and control precision. The refueling pods mounted under the wings must extend smoothly without disrupting airflow or creating dangerous turbulence. They are reinforced to withstand hundreds of cycles of extension and retraction while carrying thousands of liters of fuel per minute. Inside, the aircraft integrates advanced fuel management systems. 4 main tanks provide both internal storage and the capability to offload fuel to receiver aircraft while maintaining balance and structural integrity. Sophisticated pumps, valves, and monitoring systems ensure that fuel transfer occurs safely, even when aircraft are flying at high speeds and varying altitudes. Operationally, mid-air refueling is a delicate choreography. The MRTT must maintain steady flight while connecting to one or more receiving aircraft, often in complex formations. Automation assists the crew by controlling fuel flow rates, monitoring pressure differentials, and adjusting the boom or drogue position to compensate for relative motion. These automated systems reduce pilot workload while enhancing mission safety and efficiency. While refueling is its headline capability, the MRTT is engineered for far more. Its cargo and troop transport capability transforms it into a strategic asset beyond tanker roles. The aircraft can carry up to 270 passengers, including paratroopers, medical personnel, or disaster relief teams. Alternatively, the rear fuselage accommodates military vehicles, armored equipment, or modular pallets for logistics operations. This versatility demands careful engineering integration. Cargo handling systems must coexist with large internal fuel reserves without compromising structural integrity. The aircraft's electrical, hydraulic, and environmental control systems are designed to support both personnel and heavy equipment, ensuring mission readiness in diverse environments. Additionally, the MRTT can be rapidly reconfigured. Palletized cargo modules, medical stations, and seating arrangements are modular, allowing commanders to adapt the aircraft to emerging mission requirements within hours. The adaptability extends the aircraft's relevance across peacekeeping, combat, and humanitarian operations alike. Operating an aircraft with dual roles requires highly integrated avionics. The MRTT is equipped with modern digital flight controls, multifunction displays, and automated systems that simplify complex operations. Navigation systems ensure precise positioning for both strategic and tactical missions, while autopilot modes assist during extended refueling operations, allowing the crew to focus on monitoring fuel transfer and airspace coordination. Redundancy is a critical feature. Multiple hydraulic and electrical systems ensure that no single failure compromises mission completion. Integrated threat detection systems provide situational awareness in contested environments, enabling the aircraft to avoid hostile engagement or adjust flight paths dynamically. Powering the MRTT are two high-bypass turbofan engines, optimized for long-range cruising with heavy fuel loads. Unlike fighters or bombers that prioritize speed, the MRTT's engines prioritize efficiency, reliability, and thrust stability. The high-bypass design produces significant lift through propulsive efficiency, reduces fuel burn on long missions, and maintains predictable handling characteristics even during refueling maneuvers. Engine placement under the wings improves maintenance access, while minimizing structural modifications to the fuselage. The engines are equipped with advanced monitoring systems that allow the crew to detect performance degradation early, ensuring long-term operational readiness. The MRTT's mission crew extends beyond the traditional flight deck. Refueling operators, mission planners, and communications specialists work alongside pilots to execute precise operations. The crew coordinates fuel allocation, monitors receiver aircraft, and manages cargo or personnel transport simultaneously. Automation plays a pivotal role. Integrated mission computers provide real-time data on fuel levels, aircraft positioning, and refueling status. The system can even adjust fuel flow automatically based on receiver aircraft speed, altitude, and fuel requirements. This reduces human error and allows the crew to manage complex scenarios efficiently. The Airbus A330 MRTT is more than a tanker or transport. It is a force multiplier. By extending the range of fighter aircraft, bombers, and reconnaissance platforms, it reshapes operational planning for air forces worldwide. Its multi-role flexibility allows rapid deployment of troops, vehicles, and aid, enhancing strategic response across multiple theaters. Its endurance and payload capabilities make it particularly valuable in expeditionary operations, where infrastructure is minimal and operational tempo is high. Unlike older tankers or transport aircraft limited to specific bases or airfields, the MRTT can operate from established runways worldwide, combining logistical reach with tactical relevance. The engineering of the MRTT reflects a philosophy of integration and adaptability. Its airframe, refueling systems, engines, avionics, and cargo systems are not separate components. They are a cohesive platform designed to respond to modern air power challenges. Every detail, from fuel pump reliability to cargo tie-downs, contributes to a seamless operational capability. Across the skies of Europe, the Middle East, and Asia-Pacific, the Airbus A330 MRTT has proven its value not just as a refueling aircraft, but as a strategic enabler of modern air operations. Its operational versatility allows air forces to project power globally, extending the reach of fighter jets, bombers, and transport aircraft without requiring forward bases. This global deployment is possible because of its standardized interoperability. The MRTT can refuel both NATO and non-NATO aircraft thanks to its dual refueling systems. The Flying Boom and Hose-and-Drogue, fighter jets from the United States, Eurofighter Typhoons, Rafales, and even Japanese F-15s can rely on a single MRTT to extend their operational range. This capability creates a level of coordination and flexibility unmatched by older tanker fleets, making the aircraft a vital asset in joint operations. While refueling captures the imagination, the MRTT's transport role is equally transformative. The aircraft can carry troops, medical teams, humanitarian supplies, and armored vehicles over intercontinental distances. Its large cargo bay is compatible with standard military pallets, allowing rapid loading and unloading in both combat and disaster response scenarios. In humanitarian missions, the MRTT has delivered food, water, and medical supplies to regions devastated by natural disasters. From earthquakes to typhoons, its ability to carry personnel and cargo simultaneously makes it an ideal choice for air forces and relief organizations that require rapid response and logistical efficiency. The aircraft's long-range endurance ensures that even remote locations can be reached without relying on intermediate refueling stops. The true combat significance of the MRTT becomes apparent during the sustained air campaigns. Modern air warfare requires aircraft to maintain extended loiter times over contested areas. Without mid-air refueling, jets would be forced to return to base frequently, reducing operational effectiveness and exposing ground bases to enemy threats. During coalition operations in the Middle East, MRTTs routinely refueled fighter and reconnaissance aircraft multiple times per sortie. These operations demand extraordinary precision, as refueling often occurs at high speeds and low altitudes, requiring both the tanker and receiver to maintain steady formations. The MRTT's automated refueling systems, advanced sensors, and experienced crew combine to execute these missions with exceptional safety and efficiency. The Airbus A330 MRTT is not a static platform. Continuous upgrades ensure it remains relevant in an era of rapidly evolving threats. Modern MRTTs incorporate advanced defensive systems, including missile warning sensors, radar warning receivers, and electronic countermeasure suites. These systems provide situational awareness and self-protection, allowing the aircraft to operate in contested airspace with confidence. Avionics upgrades have enhanced navigation, communications, and mission management capabilities. Digital flight controls, integrated mission computers, and automated refueling functions reduce pilot workload and improve operational efficiency. The ability to monitor and manage fuel transfer, cargo distribution, and aircraft systems simultaneously ensures that each mission is executed flawlessly, even under high-pressure conditions. Integration into modern air forces requires more than just technical compatibility. It demands operational doctrine and training. MRTT crews undergo rigorous preparation, practicing refueling, cargo handling, and mission coordination. Exercises often involve multiple aircraft types, complex formations, and extended range operations to simulate real-world scenarios. Air forces around the world have recognized the MRTT as a force multiplier. For example, the Royal Air Force of the United Kingdom, the Royal Australian Air Force, the French Air and Space Force, and the United Arab Emirates Air Force all operate MRTTs to extend the range and effectiveness of their fighter fleets. NATO missions frequently rely on MRTTs to provide seamless support for multinational air operations, demonstrating the aircraft's global impact. The MRTT is more than the sum of its parts. It is a force multiplier. By enabling fighters to remain airborne longer, the aircraft increases the operational tempo of air campaigns. Pilots can engage multiple targets, perform reconnaissance, or provide close air support without returning to base prematurely. Similarly, strategic airlift capabilities allow rapid deployment of troops and equipment, reducing the need for multiple flights and optimizing logistical efficiency. The aircraft's dual-role functionality ensures that a single platform can accomplish tasks that previously required multiple specialized aircraft. This efficiency reduces operational costs, simplifies maintenance logistics, and increases mission flexibility. Operating an aircraft as complex as the MRTT is not without challenges. Mid-air refueling, especially with multiple receivers, requires exceptional coordination, discipline in flight planning, and real-time adjustments. Environmental factors such as turbulence, high winds, and varying altitudes add complexity. Pilots and refueling operators must train extensively to manage these variables safely. Cargo transport missions also require careful planning. Load distribution, fuel management, and structural limits must be balanced to prevent overstressing the airframe. The aircraft's mission computer assists in these calculations, but crew expertise remains essential to ensure safe and effective operations. Beyond combat and strategic deployment, the MRTT plays a critical role in humanitarian operations. Its ability to carry both fuel and cargo simultaneously allows it to support relief efforts in disaster zones with limited infrastructure. The aircraft can deliver emergency supplies, evacuate personnel, and provide logistical support in regions where ground transportation is impossible. This capability serves as a tool of soft power. Nations operating MRTTs can project humanitarian assistance globally, demonstrating commitment to international stability and cooperation. The MRTT thus becomes not only a military asset, but also a strategic instrument for diplomacy and global influence. The Airbus A330 MRTT continues to evolve. While the base platform supports standard tanker and transport operations, future upgrades may integrate enhanced defensive systems, autonomous refueling capabilities, and more efficient engines. Modular cargo systems could allow even faster reconfiguration for specialized missions, from medical evacuation to intelligence gathering. The adaptability of the MRTT ensures it will remain relevant in the coming decades. Its combination of fuel transfer, cargo transport, and strategic mobility represents a level of versatility unmatched by most other military aircraft. As air forces around the world modernize, the MRTT is poised to continue playing a central role in sustaining air power across multiple theaters. The Airbus A330 MRTT is not merely a tanker or transport aircraft. It is a cornerstone of modern air operations. By enabling extended range, rapid deployment, and simultaneous multi-role functionality, it transforms the operational capabilities of the air forces that operate it. From extending the endurance of fighter jets in combat to delivering life-saving humanitarian aid across continents, the MRTT exemplifies the marriage of engineering excellence and strategic foresight. In a world where air superiority, rapid response, and global reach are essential, the MRTT ensures that air forces can operate without boundaries. It is a symbol of adaptability, efficiency, and strategic innovation, a flying platform capable of reshaping the very way nations project power and provide aid in the 21st century.